Hello students, welcome to our channel. Today we are going to study about lens. We are studying our chapter Light, class 10 science. We are continuing from lens topic. Before this we have studied about the mirrors. So what are lenses? You have seen contact lens, spectacles, magnifying lenses, binoculars, microscope, telescope. In these all materials what we use lens. A lens, we can say it is a transparent medium bound by two surfaces. Any medium which is bound by two surfaces we called a lens. So here, this is a transparent medium bounded by two surfaces. It is called lens. This is also lens. Another in this. What we study here, first that is converging lens. Second that is diverging lens. So here what we see, one of this shape that is called converging. Here when the rays, parallel rays, strike this lens, then it converge at one point. It is a real focus. Actually these lines are meeting, so that's why we called it real focus. Diverging lines, diverging lines are those in which the parallel lines will diverge. Here when we extend it at the back, when we extend it at the back, then it seems to be comes from this focus. So here we called it virtual focus. This type of lens we called convex lens. Con means curve, wax means here outward, a curve which is outward. We have concave, con, con means a curve, cave, cave means inward. A curve which is outward, that is called converging lens. A curve which is inward, that is called diverging lens. Now let's distinguish between convex and concave lens. Convex lens and concave. A lens which has a two spherical surface curved outward, that is called convex lens. A lens which has two spherical surface. These two spherical surface, these curved outward. आप देख सकते हो बाहर की तरफ उभरे हुए ये. We call these type of lens as convex. Next, concave, a lens which has a two spherical surface curved inward. When they are inward, अंदर की तरफ हो, like this. So we called it concave lens. It is a converging lens. Here we see the line which are parallel to the principal axis meet at a focus F. It is a diverging lens. The lines which are parallel to the principal axis diverges, spreads in the area. Now here it is form a real focus. Actually these lines meet at a point. We called it real focus. Here we observe it form a virtual focus because these lines are not actually meeting at a point. It seems to be appear from this focus, so that's why we called it virtual focus. It is thick in the center and thin at the edge. You can observe here it is thick at the center and thin at the edge. Here in concave it is thin in the center and thick at the edge. Thin in the center and thick at the edge. What are the common terms here? Let's understand. We have a lens here with two surface 1 and 2. So as you complete this complete sphere and another one also reflecting sphere. So this is S1, other one S2. These are the center of the spheres. This is C1, another one with the center C2. So as you join a line passing through this, same as it is, you can say this another one. Here we are taking these two reflecting surface like this, and here we are taking reflecting surface like this, right? So here what do you observe? We have two centers C1 and C2 and a line which is passing through this, right? So here what is center of curvature? The center of a sphere whose parts from the surface of the lens are called center of curvature. The center of spheres whose part forms surface of lenses. राइट। ये जो लेंस है वो किन स्फीयर से बने, उन स्फीयर्स के सेंटर ही क्या कहलाएंगे, इसके सेंटर ऑफ कर्वेचर। वेयर C1 and C2, these are the center of curvature. Now here let's make a line passing from center to the point of a circle. This is R1. Another one, that is R2. Center of curvature, we say the radius of the sphere whose part from the surface of the lens are called radii of the curvature. R1 and R2. So here we have this concavo convex lens. One part that is concavo and another one that is convex. So that's why we called it concavo convex lens. Here as you complete it, another one, then we say it is positive meniscus. Another one, if we have here convexo concave, one part that is convex, another part that is concave. So here we called this as negative meniscus. One is positive meniscus and another one that is negative meniscus. Now let's talk about principal axis. The imaginary line that is passing through both center of curvature, that is called principal axis. Line which is passing through C1 and C2. This is called principal axis. Now optical center. What is optical center? Here what do you observe? Center of this lens, right? In which when the lines passes through this, they will not get deviated. Means the lines which are undeviated at that point, that is called optical center. From this optical center you can observe when a line which is passing through it, it always passes through one point, right? So here at this point it bends. We call this optical center the point inside a lens on the principal axis through which light ray passes without change their path. So you have observed the light when it is passing through the center, it always moves in a line. Here principal focus, we have convex lens, line which is passing through O. All the lines which are parallel to principal axis meet at a one point. So actually they are meeting. So that is convex lens and we say it forms a real focus. When light rays parallel to the principal axis are incident on a convex lens, they converge to a point. They are converging to a point. This point is called principal focus. इस point को क्या बोला जाता है? Principal focus, right? Now if you take in the another direction, again we say it meet at one point, and this point, that is we called it focus. So here we have two focus. Once it was coming from this side, another time it is coming from another side. So that time it is f1, now it is f2. So we have two focus point, f1 and f2. This is called, these are called principal foci. What we called it? Principal foci. Next is concave lens. Concave lens, we are having these two lenses. Now, two mirrors when we join like this, then it forms concave lens. A line which is passing through the center, it is called principal axis. And here a point where the lines go undeviated, we call it optical center. So now when the lines are parallel to the principal axis, fall on it this concave lens, what we see? It diverges and it appear to seem from this point. So here this is f1. When the light ray parallel to principal axis are incident on a concave lens, they diverge and appear to be coming from a point on the principal axis. This point is called principal focus of the lens. Now f1 and f2, these are the principal foci. Convex lens give real focus. Concave lens gives virtual focus. What do you mean by focal length? The distance between optical center and principal focus of a lens is called focal length. So here the distance between O, optical center, f1, that is principal focus. That is called focal length. Now let's understand here ray diagram. Here lens showing a diminished and inverted image. Here you observe in this another one. It is inverted image, means उल्टी दिखाई देती है हमें, right? बट एट वट डिस्टेंस इट इज फॉर्म, कितने डिस्टेंस पर ये फॉर्म होती है, वी नीड टू अंडरस्टैंड इट. सो लेट्स फर्स्ट अंडरस्टैंड द बेसिक डायग्राम्स. We are taking a line, principal axis. O is the optical center. A lens we are forming here. So now here we have a convex lens. This F1 and F2 is the focus of this lens. Converging surface F1, center of curvature we know. जैसे इसको पूरे कंप्लीट करेंगे तो ये इसका सेंटर बनेगा, तो इसको बोलते हैं हम क्या, 2F1. Another part, that is F2 and 2F2, which are at equal distance. Now let's understand rules for making ray diagram. First rule, that is when the incident ray is parallel to the principal axis, the refracted ray passes through the principal focus. Here we take incident ray parallel to the principal axis. Now what you observe, as a strike to the line which is passing through the optical center, what do we say, it bends. And how it bend, it always passes through the focus. As we studied in the mirror also, the incident ray, when it is parallel to the principal axis, it always moves from the focus, right? Rule number 2, that is when the ray passes through the principal focus, the refracted ray is parallel to the principal axis. So it is opposite now. When it is passing through focus, it is always parallel to it. It is a refracted ray. What we called it? Refracted ray. Now let's understand rule number 3. When the incident ray passes through the optical center, it passes without changing its direction. So now as it passing through O, we see that it is passing undeviated. Means there is no change in the direction of light. Rules for making ray diagram. Here we say incident ray parallel to principal axis, refracted ray passes through focus. Second, we are taking incident ray, passes through focus, it passes parallel to the principal axis. Third, incident ray passes through O, and now what we see, it does not change its direction. So now let's take object at different position, and let's see that how these objects will make the images. So let's understand it. Here we have a convex lens with focus F1, F2, center of curvature 2F1 and 2F2. Now what do we observe, that object when it is placed, how we are placing, we are placing it beyond 2F1, beyond 2F1. Now AB we are taking, if the incident ray that is parallel to principal axis, we know it always moves or it will passes through focus like this. The refracted ray passes through focus. Now here, our incident ray passing through optical center, we know it will not diverge and then it not deviate, and now it is passing without changing its direction. So here we observe that they are intersecting at one point. This point, if we will take, that will form an image that is called A dash B dash. Now what is position of image? It is A dash B dash between F2 and 2F2. Here nature of image, what we observe, real, as it is actually meeting, inverted. You observe this AB, it is on principal axis, and here it is formed below the principal axis. So it is inverted and it is small in size, right? Now let's take our object at 2F1. So here we are taking object at 2F1. This is object AB here. Now a line which is passing through principal axis, we know that it will pass through focus. Here it passes through F2. Now another one line which is passing through O. O is the optical center. Here it passes without any change in its direction. Now, where you observe this line intersect, these two lines intersect at C, like 2F2. So, here this is the image. Object and image, you can see that they are same in size, right? So, what is the nature here? Nature of image. First of all, we say what is the position here? That this is at 2F2. When we are taking object at 2F1, image is forming at 2F2. Next, nature of image, we say it's real, inverted and of same size. Next, we are taking object between F1 and 2F1. So let's take an object here, an object between F1 and 2F1. Now a ray which is passing through the principal axis, it passes through F2. Another ray that is passing through O, it will not deviate, it will pass straight without changing its direction. So now can you see where they intersect? They intersect after 2F2, right? Behind 2F2. So here what we observe? What is the position? It is beyond 2F2. Nature of image, here we see that it is real. Actually these lines are meeting. As you see, this is here AB and here it is A dash B dash. So opposite in direction, we called it inverted, and here it's larger in size. Now let's take object at F1. We are taking our object at F1 now. So line which is passing through principal axis, it's parallel to principal axis, it will pass through F2. Another ray that is passing through optical center will passes without changing its direction. Now can you see that they will never intersect? So here at infinity, nature, you can say real, inverted and very large image formation will be there. Now next case, when the object is between F1 and O. So it is the most important part here. Here we are taking an object AB, a line passing through its line which is parallel to principal axis passes through F2. One line that is passing through O optical center. So here they will not intersect when we extend them, but if we extend at the back side from here, surely they will intersect, right? So here you observe they intersect at a point, and that we call image A dash B dash, right? So here you observe these are not actually meeting, so it's a virtual. The state it is there, right, as the object size, and here you see that it magnified. So here we say large image form, plus we say it is virtual and erect on the same side. And here what is the nature? It's virtual, erect and large, right? So now this is all about, you need to understand it. Thank you, bye bye. If you like the video, please share it with your friends. Subscribe the channel so that you will get the notification.